Hello everyone, this is Brad, and I'm going to be going through Oomlout's Experimenter's Guide for Arduino. It's a 13-part experimenter's guide on how to use the Arduino. It goes through a lot of different cool exercises. This is video 1, so we'll be going through, it's called the blinking LED. And as we can see here, it's set up pretty simply. There's only 3 wires and 1 resistor. Right here we have a 560 ohm resistor. LED positive is wired to pin 13, which is a digital pin, and then we also have power and ground, and as we can see, power is routed to the 5-volt pin on the Arduino board, and the ground is wired to one of the 2 grounds. And now this is hooked into my computer, and we'll go up and look at the code. Okay, code is also very simple. It's accessible as the example in File, Examples, Basics, Blink. And it just loads up exactly like it shows here. Right here we have / star and star / and that's to create a comment, and anything within those areas is commented out and won't be accepted as code. And basically we also have another one, 2 /, which comments 1 line, and as we go through there's various comments through here that tell what everything does. So it's really well written out. You don't really need a whole lot of instruction from me, but I'll go through it anyway. The first portion here, int LED equals 13. This is an integer function. You're basically setting this variable LED equal to 13, and when we use that down here in void setup, this pin mode function is what tells the Arduino what to do with a certain pin. So you can set the pins to do various things, and with this pin mode, the LED, which is now 13, is telling the pin mode is telling Arduino to take pin 13 and put it as an output. Now each pin can be put as selected as an input and an output. This time we're going for an output to create the blinking LED, and digital pins can be pulled at 0 or +5 volts. So this output, now this void setup, a void setup is run initially to set up all the pins and everything, and void setup will only run once, and then it has a curly bracket start and end, as you can see here, and that will be the beginning and end. So if you had more pins to create, those would go in there, and then that runs once. Then once that's done, it goes down to here to void loop, and void loop runs until you disconnect power. Now this void loop, we're set up as an output on pin 13, and digital write will tell that pin what to do. So we're doing digital write pin 13 high, and when it's pulled, when the digital pins are pulled high, they go to +5 volts. Now this delay is set up to delay between pulled high and pulled low 1000, which is basically 1 second, so a second times 1000. And as it goes through, as you saw with the blinking LED, it goes high for a second and then off for a second. So basically you get the blinking 1 second intervals. Okay, now that we have the basic program down and the basic circuit done, we'll go through the making a better section of this project, and the first part of that is to change the pin location that the power is being sent to the LED through. And what I've done here is changed this number when we first set up the LED variable to 10 instead of 13, and as it goes down through each position this LED is in each function will then go back to this, and since it's set at 10, then we can see here in the actual circuit that I'm now connected to pin 10, and now we're blinking again. Also, one thing to note, this Arduino board has an LED on pin 13 already, so this first project doesn't really require an LED to show that this actually works. Okay, now with the pin changed, the next object of interest in this project is changing the delay time. So the time that the LED is on and off, and what I've done here down in the delay section is change this to 2000, which will then change the on time to 2 seconds that the LED is turned on, and I've left this 1000 here so it's 1 second off. And we'll go down here to the circuit and we'll see that it is on 2 seconds and then off 1, on 2 seconds, off 1. Okay, next on the menu is to play around with the brightness, try to adjust brightness. So what I've done here is change the output pin to pin 9, and pin 9 is one of the pins that supports pulse width modulation, and the other pins are 3, 5, 6, 9, 10, and 11. And what this allows me to do is change the duty cycle of the output, and what I can do is any value between 0 and 255 will give me any output from 0% duty cycle to 100% duty cycle at 5 volts. So it just basically is on and off really fast, and it's quick enough change that our eyes can't tell the difference, so it just looks dimmer at anything below 255. So what I've done here now is changed the digital write function to analog write. Now remember, digital write was only pin number and either high or low, so either on or off of 5 volts or 0 volts. Now with this analog write, since the Arduino is a digital board, we can then use this pulse width modulation to basically force it into an analog state. So this, I've changed them to analog write, and the first value is 255, so that will be full 5 volts delayed for a second. And then the second one that we had originally I've set to 100, which is more than half as long a duty cycle. That's delayed for a second. And then I also added a third one in here down to 0 duty cycle, and that's delayed for a second. So now when we go down to the circuit, we'll see that it goes bright, dim, and off. Bright, dim, and off, all in 1 second intervals. Okay, and the last portion of this first exercise is to go and mess around with the fading example, and that's File, Examples, Analog, Fading. And again, it's very well written out, explained well, and we'll go through it here. As originally, we've set pin 9 as the output pin, which has pulse width modulation, and there's 1 void loop and 2 pieces to it, and this loops until you remove power. So this function here starts it out at 0, which is 0 duty cycle at 0 volts, and fades up to 255, which is 100% duty cycle of 5 volts, in in points of 5, so 0, 5, 10, 15, and that writes it to the analog pulse width modulation, and this is then delayed 30 seconds, and then it moves on to the fade out. So this is the fade in and this is fade out, and again 255 down to 0 and -5 increments, and writes it to analog out, and then delayed, and it starts over again. So as we'll see here in the circuit, dims, goes bright, then dims, fades back in, and fades out.